Hello friends, in the previous session we have seen the first problem in which we have found the value of Vc of t and I took considerable amount of time explaining this problem. In this today's problem is also very interesting. This is an interesting problem because it has a dependent source also. Alright. So seeing the dependent source you need not get scared because the problem is quite simple. Anyway, unless you have the concepts of transient analysis, no problem is simple. So let us start with this problem here. Now they are asked to find the value of Vc of t, Ic of t with the polarities given. Don't change the polarities. Alright, and the switch is thrown up at t equal to 0. That means the circuit is open at t equal to 0 and this circuit is getting isolated there. Okay, this source is getting isolated from the main circuit. That's why the source free circuit. Now let us first find the value of Vc of t. Now Vc of t is nothing but Vc of 0 minus e power minus t by tau, where tau is equal to R equivalent into C. Alright. So our objective is first finding Vc 0. This is only Vc 0, right? It's only Vc 0. So now, as usual, Vc 0 is nothing but equal to Vc 0 plus, and that is nothing but equal to Vc 0 minus. Alright. So we have to go back in time, alright, and we can find Vc 0 minus. So that will give us Vc 0 plus, and that is nothing but Vc 0. So let's go back in time. For that I have already copied the circuit and I will paste it here. Okay. So we are back in time now. So this is t equal to 0 minus, that is t less than 0. The circuit is in a steady state condition. That means the capacitor is open to DC. Alright. So the capacitor is open to DC and this voltage will be Vc 0 minus. So because this is open circuit, I can remove this capacitor from here. Okay, so let me put it neatly. Vc 0 minus. Okay, and this switch is thrown open, right? So this switch is like this now. Okay, this is the circuit condition. No, sorry, I made a mistake here. The switch is thrown at t equal to 0. Therefore, before the switch is thrown, this is t less than 0 condition. I'm sorry, I made a small mistake there. Yeah. So our objective is to find this particular voltage. Okay. So now because it's an open circuit, there is no voltage drop across this particular 20K. Therefore, this voltage across this element, this dependent source, will be nothing but equal to Vc 0 minus. So I can put here 10 power 4 into Is will be nothing but Vc 0 minus. Okay. So once you find the value of Is, we will have more clarity in this question. So what is the value of Is? So Is is moving like this, right? So the value of Is at this particular instant 0 minus is nothing but 10 minus, at this particular area the potential is 10 minus the potential at this area. The potential at this area is nothing but Vc 0 minus. So it is Vc 0 minus divided by 5K. Remember that now this will be in milliamperes. Okay. Now let us bring back all things together. So 10 power 4 into Is. So let me just substitute the value of Is here. I'll take this Is value and I'll substitute it here. So now be careful because 10 power 4 Is is in SI units. Therefore, you cannot just simply write the milliampere term here because this is in volts. That means this also should be in volts. Therefore, everything should be in its SI units. So 10 power 4 into 10 minus Vc 0 minus divided by 5000 equal to Vc 0 minus. By doing some simple algebraic calculations, you can find Vc 0 minus to be equal to 20 by 3. And because Vc 0 minus equal to 20 by 3 volts, so Vc 0 plus will also be equal to 20 by 3 volts. So first part of the problem is over. The next part here is finding what is the tau. That means you have to find the value of R equivalent. So let us go to the next page. Let us paste the circuit once again. Okay. So to find the value of R equivalent, you have to go at t greater than 0. At t greater than 0, the switch is open, right? So the switch is open at t greater than 0. So it is like this. All right. And because I have to see the resistance as seen by the capacitor, I'll remove the capacitor and equivalent resistance as seen by the capacitor. Okay, now this might look a complicated problem to you. In the previous finding Thevenin R equivalent also, we had encountered independent sources, and we used to inject a current of 1 ampere. You find the Thevenin voltage, you find the Thevenin current, short circuit find the Thevenin current, and you used to do R Thevenin is equal to VOC by ISC. Now don't go for all those things. Let us see what is the value of IS here. Now because this is an open circuit here, in this case IS will be equal to 0, because IS will be 0 because it's an open circuit. Therefore 10 power 4 IS equal to 0, okay, which means 0 volt. Now what is the meaning of a 0 volt? A 0 volt is nothing but a short circuit. It is nothing but a short circuit. So now if you have a short circuit, and anyway this is an open circuit here, R equivalent in this case will be equal to the only resistance which is here 20k, and the current will come back here, so it is 20k. Therefore tau will be equal to R equivalent into C equivalent, which is equal to 20 into 10 power 3 multiplied by the capacitance value is 2 microfarads, right? 2 into 10 power minus 6, and this will be in seconds. So let us write the value of Vc of t. So Vc was 20 by 3 e power minus t divided by 20 into 10 power 3 into 2 into 10 power minus 6. After doing a little bit of algebraic calculation, I can find 10 power 3 minus 25t volts. Now the second part of the problem is finding the value of IC of t. Now IC of t, you know that based on this polarity, see IC is in this direction and VC is in this direction. In this particular polarity, IC is C dVc by dt. In case the polarity was different, you would have had to, or current of IC was different, you have to put a negative sign. So this is C dVc by dt. So it is 2 into 10 power minus 6 multiplied by the derivative of this term. So it is 20 by 3 e power minus 25t into minus 25. If you do this solution, you will get 333.33 into 10 power minus 6 e power minus 25t, and this is in amperes. Now this does not look good, right? So you can convert it to milliamperes. So if you multiply it by 10 cube, so this will become 10 power minus 3, this will become 10 power minus 3. So the final answer will be 0.3333 e power minus 25t milliamperes. Okay, so this is how you do this problem. In the next session, maybe 3 or 4 sessions after this also, we will be doing continuously numericals on RC circuits till the concepts get fully inside our mind. So I hope you have enjoyed this video. Please like, share and subscribe if you like this video, and I'll see you in the next lecture. Thank you.